All right, how do we factor and solve polynomials? And today we're going to focus on real solutions, okay? Well, just like solving quadratics, we set it equal to 0. Then we factor. All right, and so that's like, you factor out a common monomial first, then you can either use grouping or whatever. So we're just going to say choose a method. Then we're going to set all the factors equal to 0. So set each factor equal to 0. And then lastly, we'll find the real solutions. All right, so let's just jump right into it. Y to the 5th minus 4y to the 4th equals 0. So the first step's already taken care of for me, right? It's set equal to 0. So now, these have a common monomial. What do these things have in common? Y to what power?
4.
Yeah, the y to the 4th is in common. So I'm left with y minus 4 equals 0. Can I factor this down anymore? No, because it's just y minus 4 times y to the 4th. So I'm done factoring. So now I set each factor equal to 0. Y to the 4th equals 0. And y equals, and y minus 4 equals 0. Okay, since y to the 4th equals 0, if you were to take the 4th root of each of those, you get y equals 0. And since y minus 4 equals 0, we add 4 to both sides, and y equals 4.
That's it?
All right, so if I wanted to check my solution, I could change these to x's, put them into y equals x to the 5th minus 4x to the 4th. And then if I look at the graph, I should have x-intercepts at 0 and 4. Remember, because your solutions are just x-intercepts. So let's try another one. Let's do 4x to the 4th equals x squared. So now we have to decide which one we're going to, we need to get them all on one side, so which one are we going to move?
X squared.
We're going to move the x squared because whatever has our highest degree, we want to keep that coefficient positive. Okay? So we subtract x squared from both sides, and we have 4x to the 4th minus x squared equals 0. I can factor an x squared out of each of these. Whoops, why did I write an equal sign? So we have x squared times 4x squared minus 1 equals 0. All right, 4x squared minus 1. I'm looking at this x squared, so I have to think, well, this looks like difference of two squares. Is 4 a perfect square?
Yeah.
Yep. Is 1 a perfect square?
Yeah.
Yep. So I'm going to take the square root of each of those. So I still have an x squared hanging out. The square root of 4x squared is 2x, and the square root of 1 is 1. So I'm going to do plus 1 and 2x minus 1 equals 0. Now that I'm completely factored, right, I set each of these factors equal to 0. So x squared equals 0, 2x plus 1 equals 0, and 2x minus 1 equals 0. So if x squared equals 0, then x equals 0. 2x plus 1 equals 0, I would subtract 1. And then I would divide by 2. So if 2x equals negative 1, divide by 2, and I get x equals negative 1/2. And from doing the same thing, like adding 1, now it's a positive 1 that's being divided by 2, so x equals positive 1/2. So, if I were to graph 4x to the 4th minus x squared, I would see that it has x-intercepts at 0, negative 1/2, and positive 1/2. Okay, now let's look at 2x cubed equals 8x squared minus 10x plus 40. Okay, my first step is to set it all equal to 0. So since this cubed is my highest degree, I want to keep this 2 positive, so I'm going to move all of this stuff on the right over to the left. So I have 2x cubed minus 8x squared plus 10x minus 40 equals 0. Alright, so now I have to pick a method to factor. How many terms do we see here? 4. Whenever we have 4 terms, we should factor by grouping. Okay? Now, is there anything I can do to this before I factor by grouping? They all share 2 in common. So I'm going to factor out of 2, and I'm left with x cubed minus 4x squared plus 5x minus 20. Okay. Now, I'm going to factor this by grouping. So I'm going to group these 2 and these 2. All the while, I still have a 2 hanging out like on the outside. So, x cubed minus 4x squared, what do those share in common?
X squared.
And x squared, and I'm left with x minus 4. Okay, 5x and negative 20, what do they have in common?
5.
A positive 5, and I'm left with x minus 4.
I see what you're doing.
Okay? So now, this factors down to x squared plus 5, because these things came together, times x minus 4, and this is all being multiplied by 2. And all the while, these things have been set equal to 0. Okay, so we're done factoring. Time to solve. So what do I do with each piece? Set it equal to 0. And I'm looking for real solutions. So 2 equals 0. Does 2 equal 0? No. If there's no variable attached to it, you can just forget about it. Okay. X squared plus 5 equals 0. And x minus 4 equals 0. Okay, x squared plus 5. I'd say x squared equals negative 5. Now, whenever I take the square root of this, yeah, this is x equals plus or minus I square roots of 5. Right? Now, I'm just showing you that, but we were asked to only find the real solutions. So, if I'm going to end up taking the square root of a negative, that's always going to be imaginary. So I'm going to reject that answer. Okay? Now over here we have x equals 4 because we add 4 to both sides. And so my only real solution is x equals 4. But if I wanted real and imaginary solutions, I would have had to include plus or minus I square roots of 5. Alright, so 2x to the 4th equals 162. So we set it equal to 0. So 2x to the 4th minus 162 equals 0. These have a 2 in common. So I'll pull a 2 out. X to the 4th minus 81. Okay. So x to the 4th minus 81. This is factoring using the quadratic form. Okay. I imagine this as a quadratic, right? So my little thought bubble. If this was x squared minus 81, how would that factor? X plus 9 and x minus 9. Okay, but instead this is x to the 4th.
So it's going to be
So we have x squared plus 9 times x squared minus 9.
wow.
Okay? Because just like here, x times x gives me x squared times x squared gives me x to the 4th. And if I were to factor this all out, I have x squared times x squared is x to the 4th, or multiply this all out. You have negative 9x squared plus 9x squared, cancels all those, and 9 times negative 9 is negative 81. So, if you can factor it as a quadratic, you can factor it to the 4th power as well.
Oh, man.
Okay, now, is this fully factored?
It's 0.
No. X squared minus 9, that can factor down some more.
Every time I try plus 3.
So 2 times x squared plus 9, x plus 3, x minus 3 equals 0.
Oh, because the difference.
Whenever I set each thing equal to 0, 2 equals 0, rejected. X squared plus 9 equals 0. I'm going to end up taking the square root of a negative number, right? So this won't give me a real solution. X plus 3 equals 0. So x equals negative 3. And x minus 3 equals 0, so x equals positive 3. So this has two real solutions.